So welcome all. Today we are learning something about voice over IP. So basically this is one interactive audio video application where the voice or audio is being transmitted over internet, right? So here the idea is to use the internet as a telephone network, right? So that you could talk to other person on the internet. Your audio, your voice can be transmitted from one location to another using the internet based system. We would have heard about circuit switched networks. However, here what we are planning is how to send our voice audio on packet switched network. For this, here we are going to see two protocols. Basically, one is SIP, another is H.323. Okay, so we will discuss these both of the protocol here briefly. Okay, so we are going to see these two protocols. One is SIP, another is H.323. Let us start with SIP. So basically SIP is session initiation protocol. Okay, it is session initiation protocol. Designed by Internet IETF. So now what is this? It is an I should say application layer protocol that enables messages transmissions of multimedia, okay, on call. Application layer protocol which helps in transmitting your multimedia sessions. So it will be used to create two-party, multi-party or multicast sessions. Okay, so it will be using either UDP or TCP or SCTP protocol is there. You can, these all the things can be used. So basically this SIP is a text based protocol. Text based protocol. So basically it uses these 6 messages. It sends the messages, and each message has a header and a body. So the header consists of several lines. We will discuss these, and then these will be related to the message, caller's capability, media type, and so on. So basically what happens in a message, suppose a caller is there. So caller initiates a session, right? So for this initiating, it uses this invite message. So it sends an invite message to the callee, right? And then when the callee answers the call, then this caller sends an acknowledgement acknowledgement message. After that, whatever is going on, there will be a bye message in the end to show that okay, we want to terminate the session. Okay, then there is something called options message, which is used for query, right? You want to query about the capabilities of the callee, right? Then there is a cancel message which cancels the already started initialization process. You have already initialized some process, then it can be cancelled using the cancel measures. Then there is something called a registrar. This message actually makes a connection when the callee is not available. So in this way this SIP will work. However, let me tell you about some more things. Suppose I will tell you about the format, right? Okay, you understand there are IP version 4, email address, or maybe related to phone number, right? So in a regular telephone communication, what happens? A telephone number identifies the sender and another telephone number identifies a receiver. However, here SIP is very flexible. In this case, actually an email address or IP version 4 or a phone number, these all the types of addresses can be used to identify the sender and receiver. However, it needs this format. This is SIP format, I should say. So here you have @ this thing, SIP colon whatever your name, some identifier, and then your IP address or email address. If at all it is email address, it is okay. Phone number. These all the things. This is the format. You will have this kind of address. Now let me show you about the session. Okay, how this a simple session using SIP, how it is done. Actually, here you will have three modules. One is you have to establish the connection. So it will be establishing phase. And after that there will be communicating phase, and then after that you will terminate, right? So terminating phase. In this image, now let us see what happens. You are establishing a connection. For that you will have to send an invite message, and then the callee will respond and you will send an acknowledgement message, right? So these are the three-way handshaking protocol or kind of thing you can understand. Three-way handshake here it happens. So the caller sends an invite message. They can use UDP, TCP or HTTP to begin this communication. If the callee is willing to start the session, she sends a reply message. So then you know that after that it is confirmed with a acknowledgement message. After that the communication starts, right? So here the audio is exchanged between the caller and callee. So actually in this session you will have to use any two temporary ports. After that terminating the session, caller will send a bye message. Not only caller or callee, anyone can send a bye message. So tracking a callee. Suppose callee is actually not sitting on its machine, right? Or maybe they are this callee is roaming, means its IP address is not fixed. Maybe they are using DHCP protocol, or this is a mobile machine. So in that case what will happen, it will not have a fixed IP address. So calling a machine with its IP address will become a little difficult, right? In that case SIP actually provides a mechanism to find the IP address of the particular terminal, right? It uses a registrar. I should say registrar server. This server knows the IP address of the callee. So when a caller needs to communicate with the callee, what it does, the caller can use the email address instead of the IP address, right? So what happens, it uses the email address and sends an invite message. Okay, the message goes to this proxy server. Now this proxy server sends a lookup message. This lookup message is not part of SIP, it's okay. It is sent to the registrar server. Registrar server knows the IP address of the callee. Callee has actually registered itself. So when this proxy server receives a reply message, let me receive the reply message. So when this proxy server receives the reply message from this registrar server, what this proxy server takes is, proxy server sends an invite message to the callee, and then callee gives a OK message. This is given back to the caller. Then what happens? Acknowledgement is sent, and this acknowledgement is forwarded to the callee, and then a pure communication between caller and callee starts, right, based on the IP address of the callee. So audio is being exchanged, and in last you can terminate with using a bye message. This was all about the SIP. Now if you want to see other protocol, which is H.323 protocol. So this is something about H.323. Actually it is a standard designed by actually ITU to allow telephones on the public network. Here telephone network is there, and there are computers, right? So this actually allows you to communicate between these two. So here you have a gateway. This gateway connects the internet to the telephone network. Actually this gateway is a 5-layer device, right, that can translate a message from one protocol stack to another. So here also this gateway does the same thing. It transforms a telephone network message into a internet message, and so on. So this gatekeeper server on the local area network, this one, this gatekeeper server plays the role of a registrar server. So this is something similar to that we have seen in the SIP. We have a registrar server. This keeps track of the information of the IP address of the callee, right? So with that information, these can communicate now. Now, if you think about the protocol, basically this standard H.323, it uses a number of protocol. So it will use some protocol to establish the connection, then it will maintain the voice or video communication, right? Let me show you some of the protocols. So basically these are the protocols. You can see RTP, RTCP, and these all other things, and it will be based on UDP, TCP, IP, right? So this H.323 uses this one. I should say for compression it uses G71, G.71 or G.723.1. No problem. It uses a protocol named this thing H.245 that allows the parties to negotiate the computation methods. This Q.931 is used to establish and terminate connections, right? And H.225 is means it is used for registration, right? That is the thing. Other protocols we have already seen. Now, so what happens, how it operates? Let me show you this example. So basically, okay, let me show you. Basically what happens, the terminal sends a broadcast message to the gatekeeper. The gatekeeper responds with its IP address. The terminal and gatekeeper communicate using this H.225 message. The terminal then the terminal, the gatekeeper and the gateway, and also the telephone network, they communicate using this thing Q.931. Actually this 931 message will be used for setting up the connection, and after that they will use H.245 message for computation method negotiation, right? And after that RTP or RTCP will be used for exchange of this messages. And after that you want to terminate. For terminating you will again use this Q.931 message. So this was something about H.323 protocol. Now if we want to see something about quality of service. So quality of service is an this thing internetworking issue that has been discussed more than defined, right? So it can be informally defined as something a flow of data seeks to attain. So whenever we have a flow of data, we need to have a quality of service. So it can be applied to both textual or multimedia data, but it is more related to the multimedia since it has a flow of data. Okay. So we are going to discuss something about flow characteristics, flow cases, techniques to improve, and resource reservation, these kind of things. So let me tell you about the flow characteristic. So these 4 types of characteristics are attributes to a flow. Basically reliability, delay, jitter, and bandwidth. So we understand about reliability. Let me tell you. Okay. So reliability, actually it is a characteristic that is needed for the flows, right? So if we don't have reliability or there is a lack of reliability, then we will lose some packets or maybe acknowledgement. So because of which some retransmissions will be needed. So in that case we want the connection to be reliable so that these packets are not dropped and the other things are working nicely. Delay is another something related to the flow characteristic, right? So we want the packets to be sent and received at on time, right? So some applications can tolerate some a degree of delay, right? Like maybe in telephony, audio conferencing, video conferencing, these kind of different we need minimum delay, right? However, if it is email or other kind of file transfer, then some delay can be tolerated. Jitter is another thing we have already seen, that while transmitting, if a packet sent is on receiving side, there is a mismatch in time because of the transmission delay in between. In that case, there will be a jitter. Will be a delay between the first and the second, or whatever the sequential messages arrived, right? So actually, if there is same delay between the packets arrived, then it is okay. In jitter, basically what happens, there is a variation in the delay. Sometimes it was 2 second delay, and later on it became 3, and again 4 or 2 again. So this is a variation in delay. Bandwidth is also a characteristic of flow, where we need different bandwidth for different applications, right? So in video conferencing, we need more bandwidth for we want to send the video frames, right? Color screens information. So if you want to send suppose an email, so for that you may need I think more bandwidth, right? So it will depend on the data, right? How much bandwidth you need. That is the thing. Suppose there are other information about FIFO queues, flows information, actually how the flow is being transmitted. So, we are actually talking about scheduling. This flow, right? So we understand that we want to have this quality of service, and we can improve the quality of service by scheduling. So different flows are there. For all these flows, there will be a switch, right? So at a switch, we are receiving different flows, or maybe switch, or maybe a router, we are receiving different flows. So we need a good scheduling technique to treat these flows differently and in a fair and appropriate manner. So there are different flow techniques, so I should say scheduling techniques we already know, and which are being used here in scheduling also. So one is the first in first out. We all understand where the first packet which came will go out first, you know? Other option can be priority queue, that we will what the packets are arriving, we will check their priority, and based on their priority they can be transmitted in a different queue, and the data with higher priority will be sent first. So in this way, lower priority will be delayed. That is the thing which will be done on priority based. Other thing will be weighted fair queuing, where we will assign some weight. There are not only 2 queues, now we can have multiple queues depending on the weights. So in this technique, the packets are still assigned to different classes, and here in each class you will have different queues. Now the queues are weighted based on the priority. Okay, higher priority means higher weight. So what here you will have a round robin scheduling, and this higher weight will get more time and lower weight will get less time, and in this way the packets will be transmitted. Here you can see higher weight are getting to send 3 packets, however the lower weights are getting to send just 1 packet, right? So in this way, depending on their weight, they are able to send the number of packets. This is in weighted fair queuing. Another is leaky bucket. So here actually we are talking about traffic shaping. This is a mechanism to control the amount and the rate of the traffic sent to the network. So here for this we are having 2 methods. One is this leaky bucket, and you will also have one token bucket, right? So what happens in this leaky bucket? So if a bucket has a small hole at the bottom, what happens? The water leaks from the bucket at a constant rate, as long as there is water in the bucket. So the rate at which the water leaks does not depend on the rate at which the water comes in the bucket, right? So here in this leaky bucket technique in networking, we want to make a smooth what we call fixed rate data transfer, right? So what happens, it doesn't matter with what rate the data is coming. Maybe between here within 2 seconds 12 MB data came, and within 7 to 10 only 2 MB data comes. We keep all these in a bucket or in a queue or in a buffer, and we transmit the data with a 3 Mbps rate. So in this way we use this technique for traffic shaping. Now another thing, if you want to implement this leaky bucket, what you will do, you will have a queue and you will transmit the data with a fixed rate. A leaky bucket algorithm saves bursty traffic into fixed rate traffic by averaging the data rate. So it may drop the packets if the bucket is full. Now let me tell you about token bucket. So what happens in token bucket? So the token bucket algorithm actually allows idle hosts to accumulate credit for the future in the form of tokens. So for each, suppose tick of the clock, the system sends n tokens to the bucket. So the system removes 1 token at every cell, for every cell, and then the data is transmitted. So 1 token added per tick, 1 token removed and discarded per cell transmitted, depending on the host. Now the host gets n number of tokens, so it can be used. If they are not used, it will be kept, and sometimes one host can send multiple packets. However, the rate is constant. Okay, so this the token bucket allows bursty traffic at a regular maximum rate. So these can also be combined, token bucket and leaky bucket. These two techniques can be combined to credit an ideal host and at the same time regulate the traffic. In that case, the leaky bucket is applied after the token bucket. The rate of leaky bucket needs to be higher than the rate of tokens dropped in the bucket. So these are a few things related to this voice over IP and quality of service. Now we are talking about this IP service management, where first thing we are going to see is integrated services. Let us see this integrated services in next video.